Mapping your React code to the full system diagram. Now let's map your exact code. Const response equal await fetch parameter https colon slash slash fruit dash search dash api dot coding challenges dot dev slash search closing, then const data equals await response dot json open and close parenthesis semicolon, then set results parameter data. Then end-to-end mapping your code. So the user types user input on change. So since we have this, we're fetching something on the backend. When user change, input on change, then React state update. So React component. So when the user input something, the input on change will be triggered. So that has been prepared in React by converting it to a DOM API, and then a React state update will be React component to use state query. So a use state query, and then a use effect will trigger. So that's how we use the use state. So again, a use state is we for React to manage component that change state. So a use state therefore will have an input of the user, which is the query, and then a use effect will trigger, which is the side effect. So this is control flow, not domain data. Now fetch request, this actual code. So we have fetch this HTTPS fruit, and then JSON serialization, query string, then browser JS runtime. So as you can see in this fetch, it actually convert that to a JSON. It serializes it as JSON so that we can pass that to a browser JS runtime that it understands. Still JavaScript objects. Now OS boundary. So we have now browser, which is the JS runtime. OS system call send TCP socket. Now it becomes bytes on the wire. So those JSON bytes are still bytes. Is now being used to travel the network. That's why bytes are being used now for virtual machine, because it actually are able to send it over the network. Now Supabase slash API server. So we have TCP receive in the Supabase, then HTTP parser, then JSON parser, which is written in C or C++. So as you can see, we have started with this TCP from the other side, which is from Supabase server, which is in the third layer of OSI, and then application layer HTTP parser, it parse it. So it parse that, and then a JSON parser within this HTTP class. So there's a method that parse that bytes, which is written in C or C++. Still bytes, structured values. Now domain objects, this is your question. So we have JSON values to C structs. So it is converted to C struct code, and then domain objects. Now example, struct query, and then inside is char asterisk field semicolon next line char asterisk pattern closing. Or in PostgreSQL, heap tuple, inside we have t underscore len semicolon next line t underscore data semicolon closing. These are the main objects. Database engine, domain objects to query planner. So these are the domain objects we were talking, such as from the JSON bytes, it actually convert again by the C structs or compiler, and then turn into a domain object. Now this is what it looks in struct, and this is how it actually works in PostgreSQL. So heap tuple t underscore len t underscore data. So these are the domain objects. It's a raw data. Now database engine, we have domains object. It has a query planner class, and that query planner class will now execute the call the executor method then executor, index scan, and then sequential scan. Now binary storage, we have table pages, 8 kilobytes, index pages, column chunks. It's still a raw bytes. Now OS and CPU, we have disk. So that these bytes, coming from disk to OS page cache, it is being cached by the OS. Then CPU caches L3, L2 to L1, then register, then execution unit. Now tie it back to React. So we just finished that database concept because it's also highly related to an application layer code. So if an event handler, for example, onClick is specified on an element in the HTML source, the JavaScript code in the attribute value is effectively wrapped in a handler function that binds the value of this in a manner consistent with add event listener. An occurrence of this within the code represents a reference to the element. I think we're not yet there. Yeah. So let's get to this first. The method add event listener works by adding a function or an object that implements a handle event function. Sorry, I think we're here. Yeah. If an event listener is added to an event target from inside another listener that is during the process of the event, that event will not trigger the new listener. So if there's an event listener that is added to an event target from inside another listener that is during the processing of the event, that event will not trigger the new listener because it's currently processing. However, the new listener may be triggered during a later stage of event flow, later stage of the processing, such as during bubbling phase. So these are the syntax for adding event listener. Add event listener parameter type comma listener, and then add event listener parameter type comma listener and options, and then the add event listener type listener use capture. Now parameters type. So what is that? What is that type being discussed here? So a case sensitive string representing the event type to listen for. So it's a string representing the event type, kind of like the one that is representing that event we want to listen to. Listener, the object. So it's not a string. It's not representing the event type as a string. It's an object that receives a notification, an object that implements the event interface when an event of the specified type occurs. So these are the ones that providing the interface that receive a notification through that kind of like observer pattern, publish and subscribe pattern of the when the specified event type occurs. This must be null. So this should be not defined. An object with a handle event method or a JavaScript function. See the event listener callback for details on the callback.